we want to talk about systems of equations. Just some algebraic context about systems of equations, which came up on the last test, practice test. It was only in one problem. That's why I didn't feel compelled to tell you about it before and then do it now. And it only came up on one of the optional extra problems. It was that highest level of escalation on the optional extra problems. A system of equations is just two or more equations considered together. I guess we could say that one equation is like a system of one equation, but we'll just call that an equation. A system of equations is two or more equations considered together, usually with two or more unknowns or variables. So two or more equations. With two or more variables. Or unknowns. I'm going to be using those words interchangeably. I can't pick one. I don't know why. But we have two or more equations with two or more variables or unknowns. The solution will be values of those variables that satisfy all the equations. So a solution is a set of values for the variables that make all the equations true. A solution to the system is a set of values for all the variables that make all the equations true. If you have two variables that say x and y, a solution will consist of an x and a y. A solution will not just be like x equals 5. That's only half a solution. If you want a chance for specific values, if you want one value per variable as part of your solution, then you need the number of equations needs to match the number of variables. You need one equation for each variable that appears in your system. Number of variables must equal number of systems to get a unique solution. But you're not always guaranteed a unique solution. That's just like the minimum requirements. I'm going to say constant solutions. Because I said systems of equations, not systems of linear equations. So if you want constant solutions, what I mean by that is all the variables are given one constant, and then that set of constants fits satisfies all the equations. So if I have one equation, so what I mean by this last piece, if I have one equation that has two variables in it, there's too many things that could happen. There's a lot of solutions that could happen. So for example, let's suppose I have this statement. The sum of two numbers is 12, this sentence. This sentence corresponds to an equation. So we can write an equation that corresponds to the sum of two numbers is 12. I could say x is one of the numbers and y is one of the numbers. Plus means we're finding a sum and we're saying x plus y equals 12. This equation, we have one equation with two variables and we have a lot of different solutions. What's one possible solution to this equation? 11 plus 1. So I could say x is 11, y is 1. So one possible solution here is, I'm going to list it as an ordered pair. So possible solution. One possible solution, 11, 1. When I write it this way, I write the x coordinate first and the y coordinate second. We're just going to write it as an ordered pair. So I don't have to write x equals and y equals all the time. It's messy. What's another solution? 6 plus 6. If x is 6 and y is 6. There's another solution. What's another solution? 4 plus 8. What's another solution? I have two more colors of pen, so yeah. There's way more than that. There's an infinite number of solutions. You can go negative. What if x is like negative 5? Yeah. Right. We're looking at a line. We're just looking for points on a line. That is correct. That's my next point. So if x is negative 5, what would y have to be to make this equation true? 17. You have a negative 5 and you find 17, you now have 12. The purple pen is feeling left out. I need one more. What's another one? Negative 2 and 14. We have infinitely many solutions. If we draw a picture of what's going on here, we can draw a line. I had a certain plan for the formatting and I'm just toss it out the window. And so that's why stuff shows up kind of like Microsoft Word. If you put a space in somewhere and everything's like, oh, no one uses Microsoft Word anymore. So you don't have to worry about that kind of stuff happening to you. Specifically, the line x plus y equals 12 will have a y-intercept of 12 and a slope of -1. But this line represents all the solutions to this one equation. Infinitely many solutions because I have one equation with two variables. We have one equation with two variables, so we have an infinite number of solutions. I appreciate you all picking integers for the solutions. No one was like all pi and 12 minus pi. Incidentally, this is how I can say pick a number between 1 and 10, and you will never guess the number because I don't limit myself to the integers between 1 and 10. And you will just pick an integer. Even if I tell you I have chosen a real number between 1 and 10, there's an uncountable infinity. The probability that you guess it is 0. So, no chance. As long as, if you ever want to win the pick a number between 1 and 10, pick a real number. Make sure it's not something that someone knows like pi or e. And then everything will go fine. No one will ever guess your number. There is an infinite number of numbers that add up to 12. Because I can change, if I lower one, I just raise the other one, balance everything out. And they all show up on this line. Any questions? Let's suppose that I want to narrow this down to one solution. If I throw another equation on here, if I give you another piece of information about what's going on, suppose that the sum of two numbers is 12. And the difference of the numbers is 4. I don't want to use 4. 5. What we're looking for are two numbers where the sum is 12 and the difference is 5. Now I have two pieces of information. I've got two equations and two unknowns. This will lead us to exactly one pair of numbers, as long as we don't worry too much about what order those numbers show up. What's this first equation translate to? X plus y equals 12. Same one we had before. What does the second equation translate to? So when we say difference, we're talking about subtraction. So x minus y is equal to 5. In this case, I have assigned x to the larger number and y to the smaller number. But I just said two numbers. I didn't specify some kind of order that the number should show up. Now, in this case, we're only talking about one pair of numbers. What pair of numbers are we talking about? I didn't want 5. I didn't want 4, and I forgot I had to jump 2. I'm going to retcon this 5 into a 6. I'll edit that out. I'm just kidding. I won't edit that out. Now it'll be okay, because now 2x is equal to 18. So x will be 9. So we'll be okay with it. So let's suppose now we don't just want the sum of two numbers is 12. I want the difference of the numbers to be 6. Now I'm only talking about one pair of numbers, if x is the larger number. Two pairs of numbers because I can do them in the other order, but that's just names of numbers. What numbers am I talking about now? 9 and 3. 11 and 1 doesn't do it, right? Because 11 plus 1 is 12. That's okay. 11 minus 1 is 10. Nope. 10 plus 2 is 12, but 10 minus 2 is 8. If we just keep following this pattern down, we can just think our way through the problem, which is the best way to solve a problem. If you're like looking at this, like, oh, wow, this is small enough to just count, I'll just count. But 9 and 3. So this leads us to the solution 9, 3. 9 plus 3 is 12. 9 minus 3 is 6. What we're looking at here, this 9, 3, is going to be a solution to the first equation, which is represented with this blue line. And then x minus y equals 6 will be another line. And I'm just looking for where those two lines intersect. So this line we can write as minus y is equal to minus x plus 6, or y is equal to x minus 6. So one line represents all the solutions to that first equation. The other line represents all the solutions to the second equation. I want to find one solution that's common to both lines. So I'm looking for the point of intersection. Yes. So for this line, y equals negative x plus 12, this point here will be 0, 12. I spelled 12 wrong. Yeah. This point here will be 12, 0. This point down here on the orange line will be 0, negative 6. This point here on the orange line will be 6, 0. Making one of your variables 0, it makes it easy to find the other one in a linear equation. And then that point of intersection is the 9, 3. Yes. How did I get? So I wanted to draw a picture of x plus y equals 12. And so the way that I did that is I rewrote it as y equals negative x plus 12. So that tells me that my y-intercept. So the plus 12 means the y-intercept is 0, 12. So I plot that point. And then the negative 1 means my slope is negative 1. So from 0, 12, I go down 1, right 1, down 1, right 1. If I do that 12 times, I can go down 12 and right 12, and that'll give me the point 12, 0. Another way we could do that is to make a table of values. To draw a line, I only need 2 points. So if I plug in 0 for x, I get 12 for y. If I plug in 0 for y, I get 12 for x. Fast way to draw a line. Find your intercepts, connect them. Lines are very boring. You just need 2 points and you got the whole line. If your algebra teacher was like, oh, plot 3 points, it's because they were thinking that you might make a mistake. And so if you like plot 3 points and they don't show up on the same line, you're like, oh, ooh, one of these points is wrong. Could be that all 3 are wrong, but definitely one of them is wrong. Then I did a similar thing for y equals x minus 6. So when we're trying to solve a system of 2 equations with 2 unknowns, we're trying to look for where 2 graphs are intersecting with each other. The graph represents all the solutions, and sometimes there are infinitely many solutions, like we have on this line. If we have all the solutions of one equation represented by a graph, and all the solutions of another equation represented by some other graph, we're just looking for where they cross. If the 2 graphs don't cross, then there are no solutions. Questions? How's everybody okay? It's algebra. That's why everybody's all mad at me. I can just see it. You all look like this. That's the mad because algebra face. It's different than like mad because I'm asking you to do work face. That looks like this. Or mad because I took off points just because your answer was wrong. Keep in mind that second statement is not true. I'm not making you do anything. All the school that you do from now until the rest of your life is optional. Yeah, we force you to do those 12 years, including the 4 years of high school. An apology from me for making you do that. That's never going to cut it. So I'm just not going to bother. But this schooling that you're doing right now, y'all did that shit to yourselves. So you chose to be here. Your choice. How's everybody okay? All right. So there are various algebraic techniques that we can use to solve a system of equations. Here, we just looked at it. We just looked at the numbers. The reason that we did that is because I want to remind you of a couple of algebraic techniques that we have before I ask you to solve some systems. Whatever algebraic techniques you have been taught, they all fall into exactly one category. You're going to take your 2 equations with 2 unknowns, try to combine them somehow into one equation with 1 unknown. Because we do 3 things when we're solving problems in math. Number 1, add 0. Number 2, multiply by 1. Number 3, do a simpler problem. So we just learned some legal moves that we could do with equations. And our plan is to cram 2 equations together to get 1 equation with 1 unknown. The technique is to combine 2 equations with 2 unknowns into 1 equation with 1 variable. All of your techniques are equivalent to this. So one of the techniques that we have is called the addition method or the elimination method. Just depends on how aggressive you want to be in naming things. In America, obviously, we go with the elimination method. All I'm going to do, what we want to do is set things up so that if I add the equations together, I have a plus y and a minus y, those y's cancel out. That's why I picked these equations. I didn't want to do a lot of work right now, so make it easy on myself. Give you the hard problems. X plus x is 2x, plus y minus y cancels out. 12 and 6 is 18, and so x is equal to 9. We took the two equations, combined them into one equation by just adding the equations together. How's everybody okay? Always a good idea to pour water from one container into another next to a bunch of electronic equipment. With all your expensive kit, put it right next to where you're pouring water. Very safe. We'd have to go back and figure out what, I should just do that. Say the obvious. Once I have x equals 9, I can plug that into either one of these equations. I could say 9 plus y is equal to 12 and figure out that y is equal to 3. The idea was that we combine the two equations together into one equation with one unknown, because we know how to solve one equation with one unknown in it. Our other variation on this is called substitution. Substitution. Substitution is where we plug one equation into another equation. Solve one of the equations for one of the variables, plug it into the other equation. Still fits that description. Combine the two equations together into one equation with one unknown. So if I take this first equation and say, this tells me that x is equal to 12 minus y, and replace the x in the second equation. So now on the left, I have minus 2y. I'll subtract 12 from both sides. Minus 2y equals negative something. And so y is equal to 3. Once I have half the point, y equals 3, I can just plug it in to find the other half. Now I can dot, dot, dot. I get to write comma, dot, dot, dot. There's the rest of the problem. You don't get to do that because you're students. You don't get to say, oh, and then there's some other stuff that happens that leads to the correct answer. Only I have the power of the ellipsis. There's also the technique of just graphing. This one is very effective. If we can write y equals for either or both of our equations, then we can just produce a graph of the equations and find out where they intersect. How's everybody okay? So here are some problems I want to solve systems of equations. The first one, very much like the one that we just did, I want you to write the system down. I want you to write the system down, even if you can figure out what the numbers are just by reading the problem. First, try to solve it just by reading the problem and figuring out what the numbers are. Second, write a system of equations that represents what's going on. The second one, I clearly escalated. One of the equations is quadratic. And on the third one, that one is familiar. I have returned. It didn't show up very well, but the X is here. It's this vertical. And then Y is down here. That's that horizontal. This is so the Y is adjacent to the 51. Then there's another triangle with a different hypotenuse and an angle of 38 degrees. And this side is 1900 feet longer than Y. Okay. Okay. Great. So that second problem, I escalated by making one of the equations a parabola and not just a line. We noticed that the 2x and the negative 2x, we had opposite signs. So if I combine those together, the 2x and the negative 2x cancel out, but the resulting equation is still one equation with two variables in it. Our goal is going to be to combine the equations to get rid of one of the variables. We don't want two equations when we add together. We want one equation when we add together. The advantage that we have here is that the first equation says y is x squared minus 2x minus 3. And the second equation says y is equal to 2x minus 3. So both of those things are equal to y. So here, our strategy could be to take the second equation and plug it into the first equation. I'm going to replace the y in the first equation with the y from the second equation. Here I'm combining the two equations, and I'm going to eliminate the y from the equation. So this is going to look like 2x minus 3 equals x squared minus 2x minus 3. So when we're doing this, this is the way one of the ways that we can think about this. I'm going to replace y in the first equation with the expression for y from the second equation. And that's how we combine the two equations. We could also think about subtracting the second equation from the first equation. They're adding and subtracting, same thing, just in opposite directions. So if we could also subtract. So if I have this set up, y is equal to x squared minus 2x minus 3. And it says y is equal to 2x minus 3. Instead of adding the equations, I could think of subtracting the equations, because the 2x is getting rid of the 2x didn't help us. There was still the x squared, right? Still the x squared. But if I can get rid of the y's, then I'll just have x's. But if I add the equations, y plus y is 2y, that's the problem we had before. If we subtract the equations, so I'll minus y minus 2x, and then minus a minus 3, so it turns into plus 3. This causes the y's to drop out. X squared minus no x squared is x squared. Negative 2x minus 2x is minus 4x. We didn't get rid of the 2x, but that's okay, because that's still x. That x squared and the x, we still got one equation. We got rid of the y's. And then negative 3 plus 3 is 0. And so that leads to one equation with one variable. And so now we're stoked. I don't know if stoked is still a word for happy anymore, but it used to be. Okay, good. I just need like one person under the age of 50 out of a group of 40 that still use the word stoked, and I'm okay. That's groovy. Okay, I never say groovy, except if I'm deliberately trying to sound old. Rad. So in both of these cases, we ended up with one equation with one unknown. That was our goal. See, this one's still all over the place. It looks different than this one, but still we've got one equation with one variable. Both of those situations were pretty happy. The difference in this problem that was different than the sum of the numbers is 10, difference of the numbers is 2, is that this ended up with one equation with one variable, but it was a quadratic equation. So it's like a secret algebra topic that I just kind of threw in there. I'm like, well, I'm talking about systems of equations. Like, well, we got systems of equations, and then you like do the second problem and like, oh, fucker, that's two algebra topics: systems of equations and quadratic equations. Dick move, Leach. Dick move. I'm like, oh yeah, totally. So when we're dealing with quadratic equations, one of the strategies that we like to employ is to get everything on one side, write the equation in standard form, and then try to factor. I grew up saying the word set equal to 0, which is not a good way to phrase it. Set one side to 0. Set is also a terrible word. I really got to watch my phraseology. I'm going to say get everything on one side, like make one side 0. Get everything on one side. So if we have this equation up here, 2x minus 3 is equal to x squared minus 2x minus 3. Our strategy could be to get everything on one side, make one side equal to 0. I'm going to make the left side equal to 0 because I like to keep the x squared positive. So I'm going to subtract 2x from both sides. I'm going to add 3 to both sides. And that's going to make this left side 0. And over on the right, I get x squared minus 4x, which is the same x squared minus 4x that we had when we subtracted the equations. So our strategy is to get everything on one side, make one side 0, and then try to factor. When you factor a polynomial, that means to write the polynomial as a product rather than a sum. Stock form of a polynomial, x squared minus 4x, we're adding those terms together. We've got the polynomial written as a sum, but if we could write it as a factor, then we have factors that multiply out to 0. Now we have something useful. Because if we add things together to get 0, we have an infinite number of choices. When we multiply things to get 0, one of those things must be 0. So we're going to factor and use the 0 property. The 0 property just says if a product is 0, one of the factors must be 0. If x times x minus 4 equals 0, then either x is 0 or x minus 4 is equal to 0. The only way to multiply your way to 0 is to multiply by 0. So this says that x equals 0 or x minus 4 equals 0. So x equals 4. The advantage of this is that factoring is easy. It's good at factoring. The disadvantage is not all polynomials are factorable. Questions? Yes. Yeah. This says then factor and use the zero property. So the zero property says if a product is equal to 0, one of the factors must equal 0. So using the zero property would say this means that since x times x minus 4 equals 0, then x equals 0 or x minus 4 equals 0. So here are our two solutions. X is 0 and x equals 4. Correct. So this is only half a solution. These are only x coordinates of solutions. If in the context of the original problem, I had x's and y's, I could just take these back to either one of our original equations and figure out what y is equal to. How's everybody okay? If this particular procedure, not factoring polynomials, that should seem familiar at this point in your mathematical career. Solving linear systems, when finding where two lines cross, that should be familiar. The problem here, we're solving a nonlinear system. If that doesn't seem familiar, there's a reason for that, because we typically don't put that in front of you when you're doing algebra. We don't have a section on solving nonlinear systems. The reason that we don't have a section on solving nonlinear systems, it would consist of do something, and then that would be the end of it. There'd just be a list of problems after that. There's nothing really to talk about. You practice on solving linear systems. You develop techniques for solving linear systems. But when you get to solving nonlinear systems, the instructions are do something. And for the most part, when we're in algebra, just learning algebra, we're usually not brave enough to just try some stuff. Does that make sense? We're usually not brave enough as teenagers to just try something and have it not work out. That's our fault, not y'all's. That's our fault as instructors, because we're just fucking mean to you when you get things wrong. You know what I mean? Might not be all of your experiences, but probably at some point in your mathematical career, probability just indicates that at some point in your mathematical career, you've had a teacher that was mean to you just because you got things wrong. And then they probably got extra mad if you pointed out, it's like, oh, dude, it is literally your job to tell me how to do this. Why are you getting mad that I don't know how to do this? You know what I mean? It's like a full-on dick move. I've shown you one example. Why can't you do this thing now? I go, well, I'm 12. What the fuck you want me to do? I mean, that's just not how shit works, right? Hey, you've seen people go shoot baskets on TV, right? Yeah, you should be good at it now. And then when you miss the first one because you've never done it before in your entire life, then you get yelled at. What the fuck, man? That's what we do in math. How messed up is that? I worry about saying this because some of you are going to become teachers. And by the time you become a teacher, you're going to be in your 20s. And teenagers are going to be kind of annoying. Not because just because they're teenagers and you're in your 20s. You know what I mean? I know to teach when I first started teaching, I was teaching at a high school. Later on, when you're adults, you'll realize what a disaster a person like me teaching a high school class is going to be. I've toned down my language since then. It's disastrous, bad idea all around. But there's one thing I kind of did understand. You know, my colleagues would be like, "Oh man, I can't believe these kids and the way they're acting." Like, "Oh, so you're surprised that 14-year-olds are acting like 14-year-olds?" That shouldn't be surprising. You know what I mean? I had a class that was like right after the lunch period. This is the worst time to have a room full of students, a room full of 14-year-olds, and then try to do math. Because they were just outside, running around like 14-year-olds. Half of them have hit puberty, and only half of those have discovered deodorant, so the room was very smelly. They were all completely amped up because like running around will make you tired later in the day. In the immediate, you're still amped up. So, for those of you watching at home who had me as a teacher, yeah, I did get mad because as much as I could philosophically and mentally understand that teenagers are going to teenager, sometimes when you're in the 20s, that's kind of annoying. You know what I mean? Dick move on my part. Full dick move on my part. Anyway. All right, so there was a lot that happened today. The main thing that we want to be able to do is recognize that if we want to find out where find a solution to an equation, we can look where those equations cross. So here are those 2 points, 0, -3, and 4, 5. And if we want, since we're trying to find out precisely where things cross, we might want to look at a very accurate picture, say one that was produced by some kind of computing machine. How's everybody okay? It looks all stunned. It looks like this. It's too much algebra. Let's get on to our trigonometric business for today. What's that? Yeah, we can go over the third problem. In the third problem, I can set up the third problem. In the third problem, using the technology at hand, we've got two triangles. One of the things to keep in mind is that we have a picture. I don't need to replicate. What we've got going on in this third problem is we got two triangles. I got this one red triangle with the X and the Y and the 51. And I've got this, this blue triangle along the outside with X and Y plus 1900 and the 38 degrees. So what we're going to do is set up two tangents. because I've got an opposite and an adjacent in two different triangles. So first thing to notice, we've got two triangles. One of them is X, Y, and then a 51. Then the other one is X, Y plus 1900 and the 38. I've got two triangles, two variables, so we'll be able to make two equations with two variables and then use our mad solving equation skills. This is an algebraic way to go about this problem, because today we were talking about algebra. There's geometry that we could also throw at this problem. But today we want to talk about algebra, throwing algebra at the problem. So we're going to set up two trig ratios. This one is going to give us a tangent of 51 is opposites over adjacent. In the second triangle, we'll say the tangent of 38 is opposites over adjacent. I've got two equations with two variables. So my strategy should be to combine those two equations in some fashion to eliminate one of the variables. So this is spoiler level 1, telling you what the two equations are in an algebraic approach to this problem. So turn this off. You want to try this spoiler free. Hit pause. And then we'll go on to level 2. I recommend, so everybody ready to go on? All right. Some of you hit pause, so hopefully we're back. Now, the thing that we want to go after one of these variables to try to eliminate, and we could do it like we did in the parabola problem. I could say if, like in the parabola problem, I had two things that were y equals, and I put those things equal to each other. We'll do the same thing here. The most convenient one to grab is x. I'm going to take this first equation. I'm going to write it in terms of x. I'm going to multiply by multiplying by y. So x is y times the tangent of 51. Tangent of 51 is just some number. We can figure out what it is, but I'm just going to keep writing tangent 51 for now. In the second equation, I'm going to multiply by the y plus 1900 to get x by itself. Here, I've got a sum that's being multiplied by the tangent of 38. So I need parentheses. So in this case, I've got x equals y tangent 51 and x equals tangent of 38 times the sum of y and 1900. These two things are both x, so they must be the same. They must equal each other. Now I've got one equation with one variable. We're not fully stoked because the constants here are like tangent of 51 and tangent of 38. Yeah. But it's fine. We still got one equation with one variable. Now we've got to solve this equation. All it has is y's in it. So I'm going to get all the y on one side and all the constant on the other side. So if I, to do that, I'm going to have to multiply out this side. So I'm going to say y times tangent of 38. And I'm going to say 1900 times the tangent of 38. Now I'm going to get all the y terms on one side. Now that I've got the y out of those parentheses, I can gather those on one side. Now on the left, I've got two terms with a y in it. I'm going to add those terms together. It's going to look like I factored out the y, but if I had 5y minus 2y, I would write 3y. The 3 comes from subtracting the 5 minus 2. So I'm going to say this is y times tangent of 51 minus tangent of 38. So I factored out the y. Now I've got y times a bunch of stuff is equal to 1900 times the tangent of 38. So y, I'll just divide both sides by the bunch of stuff. we can grab our calculators and figure out what this is. And then once we have this y, we can plug it back in for this x over here. Or we could just take this and multiply, and all that would mean is multiplying whatever we get from here by the tangent of 51. If you're wondering why your answer of whatever it was, 4,041 did not work, it's because I had put the 3272. I forgot to, originally I had asked for both. And I said, oh, I'm just going to get rid of that. I'm just going to ask for the height of the mountain. And then I just got rid of the wrong answer. Sorry. I can see some of you are like all mad at me about that because you look like this. Any questions? Slide your- I do have some more problems for us to do. It turns out we've got a long way to go and a short time to get there. So we're gonna do what can't be done. We're gonna take these problems home instead of doing them today. I need some problems to work on. These are just reference angles. On one direction. In one direction, I tell you an angle and ask for the quadrant and the reference angle. In the other direction, I give you the reference angle and the quadrant and ask for the angle. So take this with you. Find this angle. So on one side, here's an angle, find the reference angle of the quadrants. On the other side, here's a reference angle of the quadrant, find me the angle between 0 and 360. All right, that's going to do it for today. I will see you all on Tuesday. Everybody have a good day. And thanks for playing.